So x-axis label means it will show A. This is x-axis label. And this is the y-axis. Suppose if you want to just display F, so I can write here F. This is, and you see the dimension is reduced now. This before things. Then legend. Title of the graph is, this is the title, dissection method visualization. And legend, grid lines, true. Grid lines means the horizontal and vertical lines like this. These are the grid lines. If you make it as a false, this will be a plain without these lines, without grid lines. Then show the plot. So this way we can display, and our root is 2.7. So you can see approximately this is the root. So for this is the value. So x is equal to 2.7. The function value is 0. Okay. Fine. Any doubts in this program? And one more point I want to discuss here. If you see the values, it is not uniform. Like we are showing the 6 decimals after the decimal point, 6 digits of the decimal point, but there are some are negative, some are positive. It is not showing uniformity. So we can have in the formatting, we can make something like +09. This plus represents a sign. See, now this is systematic now. First is for sign, then 0.6 means that is for 6 digits after the decimal point, and this is 9. 9 means the total length of the display. So total is 9 digits. It will display 9 digits. Okay. So this will be now looks nice. So we have to do some sort of formatting in the presentation, so that will give a better look. Okay. So this is for the visualization. So we can have the same code, just change this values. What are the values you want to display? What are the title you want to display? And the storage values and all these things. Okay. So this is for the visualization of a bisection method. So we can implement the same thing for all other methods also. So next, I'll move to the Gauss-Seidel method. Before going to the Gauss-Seidel method, so I would like to share some important functions that we use the Gauss-Seidel method. See, solve A comma B. This is one of the important functions to solve the system of equations. Here we need to define what is the A and what is the B. A is the coefficient matrix and B is the right hand side matrix, the RHS matrix or the constant matrix. So we have to assign what are the quotient matrix or and this one, then we can get the solutions. So even in the SimPy we have a uh, the SkyPy also we have a similar function. Okay. So we can use either of them. So generally, the more complicated and more complex form of things, we use SkyPy. Otherwise, we can use Compile. And another important function we use here is a LUA. LUA is a function which decomposes A to lower triangular and upper triangular matrix. Lower and upper triangular matrix. Okay. So these are the two important functions that we'll be using in the Gaussian method. I'm not sure about the So this is the program. This is for general system of linear equations. To solve system of linear equations, 2x plus 3y plus 9 equal to 9, 2x plus 3y plus x plus 2y plus 3z equal to 6, 3x plus 5 plus 2z equal to 8. So we are using NumPy. So import NumPy as NP and A matrix. I'm defining it as the quotient matrix. NP dot array 2, 3, 1, the row wise, and second row 1, 2, 3, and third row 3, 1, 2. And P B equal to NP dot array, the right hand side 9, 6, 8. So here I'm using x is equals to NP dot linear algebra dot solve. So here I have to give the complete path. Means this solve function is in linear algebra, which is in NumPy. So x is equals to NumPy dot linear algebra dot solve. Then we get the required solution. Okay. So this is for two variables, and this is similar one for three variables. Okay. Now this is one of the old problems where we are converting the old problems to linear system of equations. Then we are solved. So to solve application problem system of equations, a lady brought 12 apples, 6 bananas for $1 or $2 on a specific day. The next day, she brought 10 apples and 10 bananas for $110. Assuming the price of the bananas did not change in 2 days. So what is the price of one apple and one banana? So to this information, we are writing in a linear system of equations. First equation, let the price of the apple be A and price of the banana be B. So 12A plus 6B equal to 102 and 10A plus 10B equal to 110. So we are using this same code with values. Import NumPy as NP. A is equal to NP dot array 12, 6, 10, 10. B NP dot array 102 and 110. And using the function solve A comma B, then we get the required answer. So this is for general. general linear system of equations. Here we are assigning the coefficient matrix and right hand side matrix. Otherwise, we can write a program where user is going to input the values. User is going to give the coefficient matrix and the right hand side matrix. Then we solve it to get the solution. So is this fine? These programs, any doubts in this? So before going to the Gauss Seidel and the Gauss Jacobis, simple function solve a comma b. Any questions? Is it fine? Want to execute the program? Anyone want to execute the program? Okay. Yeah. Now I'm moving into the Gauss Seidel iteration method. So when we'll be applying the Gauss Seidel and Gauss Jacobis, if the given system of linear equations are diagonally dominant. So here we require we should have the equations means which are diagonally dominant. Then we are using a function called Seidel. What it will take input? It will take the input x0, y0, z0, e, and maximum number of iterations. E is nothing but the error. So how much error you're wishing? So initially I'm taking the values x is equal to x0, y is equal to y0, z is equal to z0. So for I in the range, maximum iteration, x new is, so I'm taking the equation x plus y plus z, and x plus, the equations are here, 10x plus y plus z equals to 12. This is the equation, first equation. Second equation, 2x plus 10y plus z equals to 13. And third equation, 2x plus y plus 10z equals to 40. So these are my equations. So that the diagonal elements are dominating. So it's a diagonal dominant system. Then what we'll be doing in the Gauss Seidel, first we'll be expressing x. X is equals to 12 minus 2y minus z over 10. So here x new, I'm taking x new as 12 minus y minus z over 10. Then y new. So in the y value, we'll be using the latest x value. So 13 minus 2 times of x new minus z over 10, and z new 14 minus 2 times of x new minus 2 times of y new. So here the for z we did both the updated values, x values and y values. For y only updated value of x. So x, since it is first variable, it is not having any updated value. So then this is the procedure. Now this is for printing. So print iterations I plus 1, x is x new, 4 decimal points after decimal 4 digits, y new 4 decimals after decimal digit, and Z, same thing. Now we are checking the condition. Here was a condition, absolute value of x nu minus x is less than epsilon. The updated value of x minus the previous value of x, the difference should be less than the other. Then same condition should be applied for y as well as for z. So if these three conditions are satisfied, then we say that the solution converges and we get a solution. So here we need to check all the three conditions. Now x, y, z is x cube minus z. Return x, y, z. So this is everything is in the this photo, if condition. If all these three conditions are satisfied, then it will come out of the if condition. And same thing, if the condition is not satisfied, this for loop is executed. So this for loop is executed for 0 to maximum underscore iteration minus 1 values. Okay. So we are repeating this process. Once this condition is satisfied, is a break statement is there. Break means it will come out of the loop. It will directly go to the last statement of the for loop, returns x, y, z. Okay. So this is the logic in the Gauss cycle. So that we are writing it as a function. And for each equation, we can call that function. We can give whatever the inputs want to give, like initial conditions, error, and maximum number of iterations. Then it will execute this program. So depending on the equations, we need to change the this quotient matrix. This is x, new value, and z. Exactly. So here initially I'm taking x not 0, y not 0, z not 0, and error I'm taking only up to the 10 to the power minus 4, and max iterations I'm giving 50. Now I'm calling that function. My function name is sidle. So in this sidle function, I require these three values, error and maximum iteration. So I have defined all those things and then I'm calling them. So this code is executed now, this for loop executed. So whenever the if condition is satisfied, it will come out of the loop. So here, this is a display. So iteration, final answer we got here. This is for each iteration. Initially, x is 1.2, y is 1.06, 9 is 0.948. So in 5 iterations, you can see the solution is converged. So the difference between the two values is negligible. X values in 4th iteration, 5th iteration, y values in 4th and 5th iteration, and z values in 4th and 5th iterations are almost same. Means this condition is satisfied in the 5th iteration. After 5th iteration, it is will be coming out of the for loop because of this break statement. If this condition is satisfied, it will display that solution converged and it will come out of the loop. And finally, it will print the state. They are taking the 4 digits, so it is showing after decimal 4 digits. Okay. Any doubts in this program?
Sir, this code, will you be sharing it with us?
Yeah, I will share it to the Srinivas person.
Yes, sir. Thank you, sir.
Any doubts? Okay, if no doubts, can I proceed to the next one?
Yes, sir. Please proceed, sir.
And this is Jacob iteration method. So what is the difference
It's
between
visible.
these two Gauss-Jacobi and Gauss equation is mainly that we are not updating the values. So x nu is 12 minus y minus z. The same, these are the same equations I've taken. Just to show the difference between them. So just copy this equations again. I think everyone knows that this hash is used for a comment statement. So that will not execute the program. That will help us to understand what is the operation we are doing in that particular step.
Excuse me, sir.
Yes.
Suppose I give a matrix only directly. The diagonals are dominant terms are there. 10, 10, 10 like that. Only the matrix only I am giving. Will that calculate x nu, y nu, z nu? Is there a code like that, sir? Because here you are only giving no, sir, x nu, y nu, z nu.
If you are using directly the solve a comma b, it will not work for diagonally dominant system.
Yes, sir.
For direct is the direct for like questions like I shown for that other general equations where the diagonal domination is
Yes,
not
sir.
there, the solve will work. For diagonal dominant system, the solve will not work. You have to go this way manually only, the programmatical way, this way
Okay.
only. So we
Good.
cannot use directly here. I cannot use directly solve for this problem. It will not.
Okay, sir.
It will give us some divergent solution. Sometimes positive, sometimes
Okay.
negative. That will not
Hmm.
converge. So
Okay.
for Gauss-Seidel and just especially for the diagonal dominant system, we cannot apply that solve.
Okay,
Okay.
sir. Okay, sir.
Now in the Jacobi's method, x nu, I'm not updating any updated values for x and x and y. So we are taking the values that we have got from the previous iteration only, not the updated values.
Yes, sir.
So that is the difference. So the same
Okay,
equation,
sir.
same program. Otherwise, there is no change in the program at all. Only this is a change where we are not updating the latest values.
Yes. Hmm. Yes.
Now, if we execute this program, I'm giving the same thing. I given with the error values very small. Now this was converged to 13 iterations. Was converged to 13 iterations. So the same when we are solving with the Gauss-Seidel, it was converged in 5 iterations. And when you're not updating the latest values in Gauss-Jacobi's, it took up to the 13 iterations. And final answer is x is equal to 1, y is equal to 1. Is equal to 1. Okay. So I think we got the difference. We are updating the values, but we are not updating we are not updating the latest values. Okay, that is only the difference. Just 2 lines change. Otherwise, both the programs are same. Okay. So, any doubts? Here, I've taken the error as 0.001. So, I'll do the same error there. You can see which is difference in the iterations. I think they have taken only 4 digits. No, I took 6 for one iteration. Same error tolerance. Here we got a solution in 13 iterations. Okay. Any doubts in these two programs, Gauss-Seidel and Gauss-Jacobi's?
Sir, in this particular thing, when you have run the code in the 6th iteration, we got the answer.
Yes, ma'am.
Yes, sir. So now my doubt is, sir, in the sixth iteration, you got the answer. Suppose you make maximum iteration as a 4. Is it going to give an error, sir? Because now in the sixth iteration, we are getting correct answer. In the code, I
Ma'am, if
make
you
max.
fix the iterations, it will not check the error.
Okay.
Means here,
No, will the code give an error,
I'm coming
sir?
out of
Yes.
the program, I'm coming out of the loop
Hmm.
based upon the
Hmm.
condition error. The error is less than
Okay.
this, they have to come out.
Yes.
Suppose we
Okay.
don't want to look at the error, I want only number of iterations. I want 5 iterations or 4 iterations. After 4 iterations, how
Yes.
the solution will be, you want to see. Then this error
Huh.
should not be defined.
Okay. Okay.
Okay, ma'am. So like I can
Yes.
remove this error part and here I'll fix the number of iterations.
Yes. Okay.
Suppose you want to run, irrespective of answer, I want to run it for 6 times. Then I can do that.
Okay.
Okay, fine.
Yes.
This is about the Gauss Jacobi Gauss side. Other than this, I want to go for LU decomposition method. LU decomposition method as shown in the presentation. So we'll be using LUA. This is the function. So it will decompose the given matrix A to lower and upper triangle matrix. Okay. So here, when I'm going for this program, it will take always the diagonal element of lower triangle matrix as 1. Always it will take, this is standard procedure of the method. So we have two methods, right? What is that? Two-Little method and Kraut's method. Okay. So in one method, the diagonal elements of lower triangle matrix is 1. In another method, the diagonal elements of upper triangular matrix is 1. In Kraut's method, we have this lower triangular diagonal elements are 1. But here always it will go for Kraut's method only. It will not go for Doolittle method. That's the algorithm that is fixed in the Python. Due to that, it will show only this type of diagonal elements, triangular elements. Okay. See this program. So this is in SkyPy. SkyPy.linalg. SkyPy linear algebra module. SkyPy is a package. Linear algebra is a module. In that we have this function LU of A. So here I'm importing only these two. I can import all the functions. I can put star. Otherwise, I can go only for these two. Because in this SkyPy.linear algebra, I have this many functions. Actually, I've not written all this then. I've written only important of them. We have 5 more, I think. 5 more than this. So I've just written whatever related to the mathematics. Okay. So here np.array. Here I'm displaying the here I'm assigning the Gaussian matrix 1 1 1 4 3 minus 1 3 5 3. Then the constant matrix 1 6 4. Then we have this PLU is equal to LU of A. This will give the 3 matrices L, U, and P. P is called a permutation matrix that we won't be using in solving this. So we use only L and U. So print lower triangular matrix L, print upper triangular matrix U. It is using this function automatically, it will generate the L and U matrix. And X is sol A comma B. Then this here I can use the sol because it's not a diagonal dominant. I can use the sol. Then we get the required solution. Okay. Can you just go through this program?
Sir, that P comma L comma U is equal to LU of A. That means all P, LU will have same values.
No. It will, LU of A will generate 3 arrays. One is
Okay,
P, one
okay.
is L, and one is U. I'm
Okay.
displaying only L and displaying only U.
Okay.
So P is all the permutation matrix and it gives all the combinations of that we don't require for our calculation part. So I not displayed it.
Okay.
So this function will generate 3 arrays, P, L, U in the
Okay.
order. So I want to
Yes.
display only the lower triangular and only upper triangle matrix.
Upper right, yes.
Then we use solve. And we get
Sir, on the left hand
the
side, PLU, what you gave on the left side, that alphabets are also fixed, is it? LU is a function,
Yeah,
it is
that is also
fixed.
fixed. That is fixed.
LUP is also fixed.
Yeah, that is fixed. That is the inbuilt function.
Okay.
Suppose if I change it to small u, and here if I want to put, it will not give it.
Okay.
But it is a fixed. This order only will get the arrays. Suppose if I take here u and here, it may display the value, but it is a fixed one. Second is only for lower triangular, and third is for only upper triangular, like that. Okay.
Yes, sir.
Okay. So next, I'm going for a program where user is giving the input. Where user is giving the input. Here I already given the matrix here, but I want to enter manually this matrix because for a given system of equations, the quotient matrix and the constant matrix may be different. So I want to give manually enter the values. So this is a program where we are entering the values. Okay. Suppose if I take the same matrix, here the quotient matrix values are 1, 1, 1. I'm just noting down those things. And 4, 3 minus 1, 3, 5, 3, 1, 6, 4. Okay. So here I'll use this as an input. Here I'm defining what is R int of input. Enter row size. As I told you, input function is always use a string. And we are converting that string to integer. This is called typecasting. So this typecasting is very important because all the input functions will have string. Then whatever the things required, we have to go for the typecasting. This is a typecasting. So here, this is always a string. Suppose x is equal to input, print the value of x. Then if you go for the type, this is called string. So execute this program. So I'm giving x is equal to some input, print the value x. So here I'm giving some input. Say 6. Now this 6 is not a number. This is a string. This is not a string because here print type of x is nothing but a string. Suppose if I take this as integer, I take it as integer. I'm converting the real integer like this. Because typecasting is very important. If you're not giving the proper typecasting, the output desired output is you cannot expect the desired output. Now, here you can see the difference. Here I have taken only input. Here I have taken int of input. Means whatever the value I'm giving input, that is now converted to integer. Suppose if I execute this program and if I give 6, you can see the class is int. Means the type of x is integer. Here the type of x is string. That's the difference. So this is very, very important. If you're not putting int, then the mathematical calculations will not be performed. So,
Sir, can you type a variable, sir? Can you execute the same thing and type ABC? What will be the output, sir?
here, if I'm not defining anything, it is by default it will take it as a string in the Python.
Okay, okay.
So if I'm mentioning it int, then we get it in class as integer. Now if I define it as a float, then it will give as a float. Like if I give it 10 input, then it will show it as 10.0.
Okay. No, sir, there you have put int, no, sir, int. Now, by suppose, yes, sir, there, the last one, yes, yes. X is equal to int input you have given. Now, instead of 6, you type SIX 6. Is it going to give an error, sir?
Yeah, it should. It will not convert that as a. It will not convert because it is not a integer.
Yes, yes. So it is giving an error. Yes, yes.
Yeah. Integer
Okay,
base
sir.
10 it will give. Suppose if I'm giving it as a float. So suppose if I'm giving 4, float means it will give you the decimal, so 4.0 like this.
Yes, sir.
So typecasting is very, very important in Python. So if you forget to give int or float, then it will take it as a string and you cannot get the required solution. So this is a user input. So here enter row size. I'm making it an integer because row size is a integer value. Then column size. Then I'm creating an empty array. Then enter the elements of the matrix. Here, first, when I takes the values 0 to r minus 1. Suppose if I take your r value as 3. So I will take the value 0, 1, 2. Indexing starts from 0 in Python. So I will take the value 0, 1, 2. So for I is equal to 0, it will create an empty row, a row with no elements, blank. Next, so j in range C. If I give the C value as 3, again it will take the value from 0 to 2. Now I is equal to 0, j is equal to 0. Whatever I'm giving input, input, whatever the number I'm giving input, it will accommodate in the 0, 0 position, 0, 0 index. Next, it will take the j value. Because this problem is not completed, it will take the j value as 1. And again input, it will append that value to the previous value. Means first 0, 0, then it will in the second in the same row, second element will be the whatever the input value I given. Next, for I is equal to 0, j is equal to 2. Then it will go to the 0 to position and it will append that value. Now this first row is completed. Now it will complete row is appended to the array. First row is appended now. First row is appended. Next it will go to the for loop again. Now I value is 1. It will create another empty row. That is the second row now. I is equal to 1 means second row. then j is equal to 0. So it will take 1 0 position, then it will ask for one, it will prompt for input. So 1 0 position is entered, appended, then 1 1, then 1 2. So second row is completed. Then it will come back here. It will append the complete row to the matrix A that is in the second row. Again, it go to the I is equal to 2. Again, third empty row will be created. J is equal to 0. J is equal to 1. J is equal to 2. So 3 elements it will append. So third row. So third row get appended here. This way, row wise, we are appending the elements. Is that clear? I think the yesterday previous day speaker might be to explain this, but this is a my way of writing. So is this clear?
Yes, sir.
So
Clear.
the values for giving input that will append in this fashion. Okay. Next again, P constant matrix. It has only one. One loop is enough because it has only one column. So j is equal to I in the range. It will take the append first value, second value, and third value like that. Then I'm using PLU, LU decomposition, and LU, then solve A comma B. When if you execute this, and I'll give the same matrix what I given for the previous problem, 3 rows, 3 columns. Now enter the matrix values. So matrix values 1, 1, 1, first row, 4, 3, -1. Then that is the second row, 3, 5, 3. So that is it is completed. Quotient matrix is completed. Now enter the right hand side matrix. That is 1, 1, 6, 4. So this is a lower triangle matrix. This is upper triangle matrix, and we got the same solution. 1, 0.5 minus 0.5. 1, 0.5 minus 0.5. Okay, this is a user input matrix. So this completes the LU decomposition. So here in this session, I completed the Gauss-Seidel, Gauss-Jacobs, then LU decomposition and general way of solving system of equations. Any doubts? This two for loops is important because how the values are entered and how the values are get appended, that is important. Any doubts?
No, sir. No doubts.
So I want to show some more programs which might not be in our curriculum, which might not be in our syllabus, but that might help you in future. So this is the program. This is a program to evaluate the double integral in Cartesian coordinates. So I have done some experiments on all the type of problems. So I want to share it to you. So from SymPy, import star x comma y symbols x comma y. So this symbols is used for the, as I told you, for independent variables. Then double integral with constant limits. This is integrand is a function. Integrate is a function, and this is f of x comma y. So my problem is here integral, double integral x comma y dx dy, x limit 0 to 1, y limit 0 to 1. So this is my problem. So double integral xy dx dy, x limit 0 to 1, y limit 0 to 1. So here I've taken the constant limits. So constant limits, generally we can do the integration in any order. So if we go for the integration, this is nothing but 1 by 4. Next, with the variable limits. So with variable limits, double integral, integrate, same xy. Now here x limits are 0 to y. So first, whichever is having a variable limits, that should be defined first, then constant. If I write y0, 1 here and x0, y, then the resultant function will be in terms of y. Suppose you try this one. Like this. So this is wrong way of giving, but it will give the answer. But in terms of, actually the answer is 1 by 8. It should be constant now. Definitely it is constant. See, this way I got it. X by 2 limits is for x0 y. X limits is 0 to y. I final answer is x by 2. But this is wrong. So now we go to correct answer. So this is a program for double integrals. A similar one for triple integral. So from SymPy import star x is equal to symbols. We can use in a single line or we can do in multiple lines. Okay. Either we can use a single line, all the 3 variables in at a time, or we can use separately like this. Now triple integral, integrand function. Now this is a triple integral x, y, z, dx, dy, dz, x limits 0 to 1, y limit 0 to 1, z limit 0 to 1. Okay. So this answer is coming to be 1 by 8. Here I cannot do it manually. So next with variable limits. Here exponential of z, then z limits 0 to x plus y. Z limits are in terms of x and y. So it is depending on 2 variables. Z limits are depending on 2 variables. That should be assigned first. Then y limits are depending on x. So y limit 0 to 1 minus x, that should be given second. And then lastly, at the end, we have to give the constant limits. So we got here triple integral with variable limits as 1 by 2. Okay.
Sir, for infinity, how will give, sir? Any symbol is there, sir? Suppose limit is from 0 to infinity.
Infinity, it will not work well. It will only for finite. Infinity,
Okay,
it will not work. So
okay, infinity it will not.
The program will not take the infinity value.
Okay, okay, yes.
So either we need to convert them into beta gamma function, or we have an inbuilt beta gamma function also in this. So we can make use of that. So infinity
Okay,
is
sir.
will not work. Only the finite values.
Okay, sir.
Um, so that's all I have. These are the programs I have. Any doubts or anything like, because I don't want to touch the differential equations that is scheduled for tomorrow for you. So uh, then I have one more program for that. This is the gradient, divergence, and curve. These programs. So in the Jacobian, somebody asked how to go for the partial derivative, means without using the inbuilt function. So we can use this way. So here, gradient I'm going, the symbols x, y, z, the symbols I, j, k, then function x, y, z. So this is the scalar function. This is a scalar potential function. Oh, sorry, scalar function. Dx is the dou f by dou x. This is dou f by dou x. This is dou f by dou y. Then this is dou f by dou z. Then what I want I into dou f by dou x plus j into dou f by dou y and k into dou f by dou z. So this way I can present like I, y, z, j, x, z and k, x, y. Or we can put using the let's see, or directly we can use this. Don't get it wrong.
Sir, please send this PPTs also, sir.
Sir, sorry.
This PPTs also please send in the group, sir, later.
So you want this PPT, sir?
Yeah, PPTs also
Yeah.
you please put in the group.
Okay,
sir.
I'll share it, sir. Whatever the
Okay.
material I have
Yeah,
shared with
thank
you,
you,
I'll
sir.
share all those things.
Yeah, sure, sir. Thank you. Thank you very much.
Okay. So this is another way of displaying the gradient. So dx, dy, dz, then gradient or grad is equals to, this is a, understood that this is the I component, this is a j component, and this is a k component. Then this program is for the
Just how
divergence.
sir, I have a small doubt in the previous one, sir. Can you show the outcome, sir? Previous, yes, sir. Below, sir. Yes, yes. Sir, in that print command, you have given dx star I, but in the outcome I star yz, why it came, sir? It should be y star z star I, no, sir.
Actually, it is a symbol, no, madam. First of all, it is a symbol and it is a function. So symbol, next function is coming.
Okay, but sir, what is in the print? You are given dx into I. So dx value should come first, then I should come appear, no, sir, in the output.
Actually, here it is a symbol. It is not actually numerically multiplying. We are just
Okay.
concatenating the symbol.
Okay, so the concatenation, what will
Yeah,
come in
just
the
a
beginning?
concatenating because this is not a value. It is a function. No? It is a function. So
Okay.
it might be giving a symbol first, then this one. Even if I give this way, suppose I star, I star y. Suppose if I give like this, even then I should get the same thing. See, same thing.
Okay.
This is a symbol. Symbol means it is not actually multiplying. Only for display purpose, I am doing that. So that it should be something like
Okay.
I component into I, J component to J, like that.
Okay. Okay.
Only to make
Okay,
it
sir.
show that it is showing something like an array, sorry, vector.
Okay.
So
Yes, sir.
then divergence here F1. So this is dou F1 by dou X plus dou F2 by dou Y plus dou F3 by dou Z. So here I'm giving input values as F1 is X square, F2 is Y cube, and F3 is XZ. So F is array of F1, F2, F3. Then here we are calculating the differentiation with respect to I. Here I means this X, Y, Z. This is in the order. S plus means 0 plus differentiation of F of I means this one. F1. F1 differentiate with respect to variable of I means X. Then plus second one. Already the first one is done. Dou F1 by dou X is done. Next, I is equal to 1. First initial I is equal to 0. Next I is equal to 1. F of 1 means this is F of 1. This is F of 0. This is F of 1. F of 1 derivative with respect to 1. Variable of 1 is Y. Variable of 0 is X. Variable of 1 is Y. So differentiate F2 with respect to Y. Then that is added to the existing value. So we got out 2. Now again third one. I is equal to 2. F of 2 means F3. F of capital F of 2 means F3, comma, variable of 2 means Z. So differentiate this with respect to Z, then add it to the previous one. So now we completed all the three, 0, 1, 2. 0 means dou F1 by dou X plus 1 means dou F2 by dou Y and 2 means dou F3 by dou Z. So we are adding, then we got this final answer. Divergence is the scalar quantity. So 3x plus 3 into y square. Okay. So any doubts?
No, sir. No doubt, sir.
Next, I move to the curl of a given vector. Same, I'm using the same differentiation DIF for partial derivative formula. Now, simply import star numpy array. For this array purpose, I'm using this numpy. So x, y, z is equal to symbols of x comma y comma z. F1 x, y, z. F2 3 into x square y. And F3 x minus z square into y square plus z. This is one F3. Now I'm taking a point x is equal to 1, y is equal to -1, z is equal to 1. So we have a substitute function. It will substitute the values at this point. Okay. So I am defining it is not an array. Now I is a some variable. So I is differentiation of F3 minus y minus differentiation of F2 comma z. So this we can get through the determinant one. I, j, k, dou by dou x, dou by dou y, dou by z, F1, F2, F3. So accordingly, I written this program. Okay. So I component will be derivative of F3 with respect to y minus derivative of F2 with respect to z. J, negative of differentiation f3 comma x minus differentiation f1 comma z. K, differentiation of f2 comma x minus differentiation of f1 with respect to y. So this is the according to the curve determinant. So curve is equals to array of I comma substitute this points, means it will substitute this point in I. So whatever the resultant we get here, it will substitute that. So if only can display this also. Print I. Like this, it can print I. So this is there. Now in this one, we are substituting 1 minus 1, 1. So this is plus 2. So this is the I component is plus 2. Same. If I want to display J, J means this one. Now substituting the points, x is equal to 1 minus 1 into minus 1 minus 1 minus 1 minus 1 square. So minus 2. So K 6xy minus xz 1 into minus 1 minus 6 minus 1 minus 7.
Sir,
So
that
this is the
SU,
point.
sir, that
Huh?
SUBS is a inbuilt function, or what is it, sir? SUBS substitute?
This is inbuilt function.
Okay, that is inbuilt. Okay.
Inbuilt function. Whatever this is a function. This is a function actually. I is a mathematical function. In that function, substitute this point.
Yes.
Like that.
Okay.
Okay. So these are the programs I have. Any doubts?
Or is there any queries?
No, sir. No queries, sir.
Okay. Thank you, Mahesh, sir, for your valuable time. Thanks once again. Tomorrow again we will start at 4 o'clock on differential equation. Thank you.
Thank you, sir. Thank you for giving this opportunity.